Okay, the first thing that I want to talk about is the change of base theorem. So you will want your calculator. Okay. So I would not write this one down because this is not the one that you're going to use. But just in general, if you have log base a of x, you can find the approximation for a logarithm by doing log base b of x divided by log base b of a. Okay? It doesn't actually matter what the base is. However, what base is in your calculator? What else is in your calculator? E. You have base 10 and you have base E. Now, yes, technically, what? The calculators that you have, there probably is a way for you to be able to plug anything in, but you need to understand the change of base formula because it will be beneficial to you later on in your math career. All right? This is what you used last year, and this is what I want you to understand. Okay? In your calculator, log base a of x, you're going to take log of x divided by log of a, and it'll approximate your logarithm for you. Okay, you could also use the natural logarithm to do the change of base formula. It really doesn't matter which one you use as long as you're using the same base, okay? But what you need to remember is you need to take the log of what's inside divided by the log of the base, okay? Now before we actually practice this in our calculators, why do we have logarithms? Yeah.
So we can solve for this.
Okay, so we know that 3 squared is 9, and we know 3 cubed is 27. Well, there's a lot of numbers in between there. Don't you agree? So what if I want to take 3 to a power, and I want it to be 20? Okay, we can do that with the help of logarithms. Okay? So, with your calculator, we are going to approximate log base 4 of 25 first. And I actually have I thought I did. Can I not open it? I meant to open my camera. Oh, there it is. Okay, so if we are going to evaluate log base 4 of 25, you are just going to type in log of 25 divided by log of 4. Please be careful. Don't be in too much of a hurry. When you press any of the logarithm buttons, it'll open a parentheses. So when you type in 25, you need to close the parentheses before you hit the divide button. So log base 4 of 25 is 2.322. Okay, go ahead and find this one for me. Log base 2 of 12. Log base 2 of 12. Grace, what do you got?
3.585.
Awesome. Okay? You will have a question on your quiz that'll ask you, use the change of base formula to evaluate this logarithm. Please know how to use your calculator. Okay? I know right now it seems easy, but if you don't practice it, you're not going to remember it. Okay? And it's really disappointing to miss the easy ones on the quiz. Okay. All right, good. Next, we are going to talk about some more properties of logarithms. So since logarithms are exponents, they have very similar properties to that of an exponent. Okay? So let's talk about a couple things. If we were to multiply x squared times x cubed, what do we do with our exponents? Say it louder, remember. We add them. This is the same thing as x to the sixth. All right? So along those same lines, logarithms are exponents. If we have multiplication inside of our logarithm, then we can write it as the sum of two separate logarithms.
Do we have to expand and condense?
Huh?
Uh,
I don't feel it would be necessary to write this down, but please understand that the same properties are going to be true for natural logarithms. Okay, it's just log base e. Okay, so just understand that these properties are going to be the same there. Quotient property. Okay, we talked about this a little bit already. If we are dividing with the same base, what do we do with our exponents? We subtract them. So if we have any sort of division inside of our logarithm, okay, so here's our division, then we can write it as the difference of two logarithms, where we have log of the numerator minus log of the denominator. Okay. Notice how the base stays the same. Okay, and we have the same property for an after. Nod your head if you remember these from last year now that we've been going through them. Good. That's why we're going to go kind of quickly through them. Okay, and our last property is, why are you go? I have my screen said the power property. So if I have x squared raised to the power of 3, what do we do with our exponents there? We multiply them. So if we have anything raised to a power inside of our logarithm, then we are going to bring it out to be multiplied in front of the logarithm. So we bring that exponent out to be multiplied. All right, I'm going to give you 4 examples, 2 each, and then you are going to do some together at your table to finish out our notes, okay? So please write these 2 down. We are going to expand these 2 logarithms. Write them down and we're going to do them together. Okay? So, first of all, we have a product inside of that logarithm, right? So we need to write this as 3 separate logarithms that are being added together, keeping it as base 4. Is this completely expanded? No. We have an exponent right here inside of our second logarithm. So we need to write log base 4 of 5 plus 3 log base 4 of x plus log base 4 of y. Okay? Bless you. The second example, that square root is a little intimidating. What can we do with it? We just leave it? Change it to a power. What would that power be? Huh? Okay, so this is the same thing as 3x minus 5 to the 1/2 power over 7. Okay? If you have any sort of radical, change it to a power and then expand it. So since we have division inside of our logarithm, we can write this as the natural log of 3x minus 5 to the 1/2 minus the natural log of 7. Is this expanded? Nope. We need to move this power out in front. Okay. Now, here's where some people get hung up. This is as expanded as we can go. If there is addition or subtraction inside of our logarithm, there is nothing we can do. We have to leave it as is. We cannot break it up. Okay? Kind of like a square root. Okay? If there's multiplication, division inside of our logarithm, we can break that apart. But addition, subtraction, it's kind of stuck there. Okay? All right, let's do some condensing examples. Here, I'll do a screen shake so you don't get too overwhelmed. Okay, go ahead and write this example down. Okay, so the first thing that I would look for when you're condensing are any exponents. Okay, we have this 2 multiplied right here. It needs to become an exponent. So the natural log of x plus 2 the quantity squared minus the natural log of x. And then since we have 2 logarithms that are being subtracted, what do we need to do? We need to divide, but make sure you are dividing inside of 1 logarithm. We're dividing inside of just the 1 logarithm. Last example, and then I'll be done talking to you for a little bit. Do not forget your order of operations. Anything inside parentheses needs to be taken care of first. Okay. So inside our parentheses, we have addition, which means we can write this as log base 2 of x times x plus 1. Don't feel that you need to write that as x squared plus x. You can leave it as x times x plus 1, okay? It's not going to change anything that we do, okay? Then this 1/3 power, or that 1/3 becomes a power, so you can do one of 2 things. You can write it as x times x plus 1, all of that to the 1/3 power, or you can write it as the cubed root of x times x plus 1. I don't care which one you do, but understand that they do mean the same thing. Questions on either one of those examples? All right, I have 7 problems for you to get through in the next 16 minutes. Okay, that's just over 2 minutes per question. By the time I get done talking, probably 2 minutes a question.